Hi everyone, today we're going to be doing a programming tutorial for the LEGO Education Spike Prime Robot Kit. We're going to be doing a line following tutorial using the color sensor and light reflection. First, you're going to need your Spike Prime LEGO kit. Any of the robot models in the Spike Prime software will work for this tutorial. You just may need to adjust the specific values in your code. I'm using the primary education robot, but you can use any of the models. Our objectives for this programming tutorial are to build a program that uses color sensor to follow a line. And we're going to discuss some best practices for light reflection and color sensor use. So first we're going to talk about the color sensor. The color sensor is able to detect color changes on a surface. So for example, the first LEGO League mat has a lot of different colors on it. The color sensor can mostly detect those colors. The color sensor can also detect light reflection. So on the first LEGO League mat, you have white lines, you have black lines. The sensor is able to detect the light reflection off of those colors. So for example, black reflects less light than white. White reflects a lot of light, black doesn't. So our example code we're going to be doing today, our objective is to deliver a group of minifigures to the museum zone on the first LEGO League Masterpiece game field. So our main steps, so our kind of pseudocode, right? Pseudocode meaning programming and code, but in plain English, is we're going to start in the left home area. And I have a map on my next section here, and you'll see that. Follow the black line using light reflection in the middle of the field. And then we're going to navigate to the delivery zone from the end of the black line. And then we're going to navigate back to the left home area where we started. So the basic outline of our movements here is we're going to start in the red or left home area. And then we're going to follow this red set of arrows off the black line. And then here we're going to stop. And then we're going to use our movement motors to move forward. Then we're going to make a turn. We're going to do our delivery of our orange minifigures in the museum zone, which is number 4, mission 4 here. Then we're going to back up, and then we're going to turn around, and we're going to return to the home area. So first, you want to connect your robot to the Spike Prime software, whether that's via wire or you're connecting via Bluetooth. Then we're going to select the Spike Prime Hub icon in the top left corner of your software. Then once you open that, it's going to give you a display with your battery level. Mine is at 0. The name of your Spike Prime hub. And then it's also going to show you what's actually plugged into your hub. So here I have 3 motors plugged into my hub. I have 2 medium motors and I have 1 large motor. I also have a color sensor plugged in. And also it'll show you your gyro angles here, but that's not important for this tutorial. So first we're going to click the drop down under our color sensor icon, which I have plugged into port C. And then once you click that, it should show you several options here. You're going to have color, red, green, blue, and then reflect. We're going to select reflect. It usually defaults on color. It's going to default there, but we want it to use reflect. And the reason for this is that reflection is much more reliable than detecting color changes with the Spike Prime robot. It's just more exact, and also it works more of the time. So now we're going to go ahead and we're going to start making some code. So I'm going to give you a step-by-step on how to do the code, at least for the educator version of the robot, but you can go through and change the exact rotation values. I'm going to be showing you the values I use to get my code to work. So first we're going to set our movement motors to A and B, so ports A and B. That block is on the bottom of the movement tab here in the Spike Prime software. And we just always want to start with this block just so the robot doesn't get confused over which motors it's moving. If you have 2 motors, it's not going to get confused. It only has 2 motors. But since I have 3, some of you may have 4, it's best to set your movement motors so that the robot knows what you're trying to actually move. Then we're going to set our movement speed to 30%, right? That block is down here. And the reason for this is when we're using sensors with the LEGO robots, It's really important to go slow. And the reason for that is that the robot has more time to correct itself if it's moving slowly than if it's moving fast. And what I mean by that is, let's say your color sensor's looking for a specific color and it can't find it in time and your robot's moving too fast, it's going to veer off course. And you'll kind of understand that as we go through the tutorial here. Then we're going to use just a generic move forward code with 10 rotation block. Remove that in, and we're going to set it to 1 rotation. And now we're going to move on to our next part of the code where we're going to actually add an if statement block. So we're going to grab the if else block from our control tab. Then we're going to add a start moving block to the top and then a start moving block to the bottom. Our top block is going to say start moving to the right, and we're going to set it to 50 degrees. Our bottom one is going to be to the left, and it's going to be set to -50. And the reason for this is so that we can move back and forth, left and right? As I previously stated, going slower allows the robot time to self-correct. This is the self-correction I am referring to. So while we're following the line, it's going to basically say, if it sees the black line, it's going to move right. If it doesn't, it's going to move left. And the reason for that is it's going to just keep moving right, and then once it loses the line, it'll go back and correct its course and move left. And then we're gonna add a repeat until block, and then we're gonna throw our if statement inside of that. So now what we're gonna do is we're gonna add our color sensor block from the sensors tab. We're gonna set it to port C because that's where our color sensor's plugged in, at least on my robot. That may be different on yours. Then we're gonna set it to less than 15%. And what this is doing is it's saying if the sensor has a reflection level of less than 15%, it's going to move right. So if it sees a black color, right, it's going to move right. If it does not, else, right, if this is not the case, else, it's going to move left. So if it sees white, it's going to move left. So basically, the sensor is looking for that black color, and then it's going to do the movement right. And if it loses that color, it's going to move left. So less than 15%, generally speaking, is the color black in terms of the Lego Spike robot. White usually has a reflection value of greater than 55%. So if we were going to do the inverse of this, we could set it to say doing white instead of black. Then we'd say more than 55%. Now we're going to go ahead and add a reset timer block between our movement and our repeat block. What this is going to do is it's going to reset your program every time you're trying to use it. And reset the timer. And now we're going to add a timer. So we're going to add an operator block that says, blank, right, this oval shape, is equal to 10. And we're going to set it to 10. So that's saying 10 seconds, right? And then we're going to add the timer block into that oval so that its timer is equal 10 seconds. And what that's doing is it's running our repeated function for 10 seconds, and then it's going to stop. And now we're going to add a stop moving block to the end so that it does stop after it's repeated it for 10 seconds. Now, in theory, your code can follow a line now. Now we have to figure out how to deliver the minifigures. So first, we're going to make some generic movement code. So after we stop moving, right, we're going to stop moving at the end of the line we're following. We're going to have to maneuver over to the delivery area. So for my robot, it's moving forward 2.5 rotations. Then we're going to set motor B to run to the right for 1 rotation. Then we're going to move forward half a rotation and backward, right? So we're delivering here, and then we're moving away from our cargo. Then we're going to add these 4 blocks to the end of our previous code. Now we're going to have our motor B run to the left for 1 rotation. This is going to be our return code, basically. So we're turning around and moving back to home. Then we're going to move backwards for 2.5 rotations. Motor A is going to run to the left for 1 1/4 rotations. Then we're going to move forward for 4 rotations. So this is going to turn us around, and this is going to return us home. Then we're going to add all 4 of those blocks back to the main program. So here is an example of the code. As you can see, we're moving back and forth. The robot's self-correcting as we follow the black line. And we have our orange minifigures in our front cargo zone. Now the robot's going to stop and then move forward. Then we're going to turn left. We're going to deliver the items back up turn around, and now we're going to flip around and return home. So the basics of this code, obviously we're using a previous year's game map, but this can be applied to every year of First LEGO League competition or any application where you're trying to do line following code. You could also have it follow the white line too. Say you wanted to get over to the zone in the top left, you could have it follow the white line here and then veer off rather than going this way. You can also program the color sensor to stop at a black line, but that's another simple tutorial. So I hope that everyone has learned something from this and that you found it helpful. Make sure you subscribe if you want to see more tutorials like this. Leave a comment. Tell me if I missed anything. And thank you for watching. See you next time.